In this video, we're going to review how to make and use a tree diagram to figure out theoretical probabilities. So what I've got here is the probability tool from FishMath. It's linked off of FishMath. It's a CMP3 tool though. And I've got my compound event. So two different events here. The first one being a fair coin, and then a spinner with sections blue, red, green, and yellow. So this actually will produce a tree diagram for us with this tool. If you look down below at the bottom left corner, there's a little tree diagram looking symbol. That'll make it for us, but we're going to use that to check our answer. So we have to think about how to make a tree diagram based off all these combinations. And all you really need to know is all the different options, outcomes for each of the events to then pair them together. So I'm going to add this in. This is not in your note packet, but I'm going to use this example that I just made up to give you an example of another tree diagram so that I don't have to do all the pages of the packet for you, because I don't want to do that. So I'm going to add this in. If I go to my notability here. So it was a coin. So the first option here, so my event 1 was a coin. So I'm going to put that up here. So coin, and the other one is a spinner. So it's basically like the event 1 and event 2. Okay. I don't like how I wrote that. Let's try again. A little better. Okay, so when we do our coin flip, that's the easy one to start with. Heads or tails. Those are the only options for a fair coin. Heads or tails. Okay. Then off of each of those, we're going to put the options for the second event, the spinner. And if we go back to our spinner, you'll see here that the spinner was blue, red, green, and yellow. So those are our 4 options that we're going to use off of each of the heads and tails. So blue, red, green, yellow. Does it matter the order I write these in? Absolutely not. Blue, red, green, yellow. I usually write them in the same order for both parts. That way I don't lose track of one or mess something up with that. So off of this, I can then figure out all the possible outcomes of our compound event by just following each branch. So heads and blue. So heads and blue. Now you could put a comma in between these. You might see it with a comma in between those to kind of connect them, or separate them, I should say. But it doesn't really matter. Heads and red would be next. Again, you could see it like this. Doesn't matter. Heads and then green would be next. So I follow that branch. And then heads and yellow. So every one of these branches, so this is that outcome. This is that outcome. Same thing here. And then same thing here. That's where I'm getting these from. And then for the bottom, very similar, basically the same thing, just with tails instead of heads. So the total number of outcomes here, if there's 2 options for the coin, 4 options for the spinner, that makes a total of 8, because it's 2 times 4. So 8 different possible outcomes. Then I could ask questions like, okay, what's the probability of getting heads and then blue? Well, that would be happen 1 time. You can get it out of 1 time out of 8 total possible events. So there you go. I could ask, what's the probability of just heads? Well, probability of heads happens 4 times out of 8. So there's my probability for that, 1/2, which should make sense because the coin is 50-50. All right, if I said, what's the probability of, let's say, how about yellow? Well, that happens again. There's 1 color out of the 4, which would be 1 out of 4, or 2 out of 8, because it happened 2 outcomes out of possible 8 total. So that's the same thing as 1/4. You could also say, what's the probability of getting blue or red? Okay, well, how many blues or reds? So then you just count them. 1, 2, 3, 4. So that'd be 4 out of 8, because again, our spinner, if I said blue or red, that's half the spinner. And we're not using the coin at all, so it should make sense that it's a 50-50. All right, so then you'll see in your packet here, if you go to, this is I think page 26, yep. So page 26, you're going to do the same kind of thing. You're going to draw a tree diagram to show all the possible outcomes, and then you're going to use that to find probabilities. So I'll do one more with you here. So 6-sided die, it says, and a black and red checkerboard. So 6-sided die, our options for that. So 6-sided die. Our options are obviously 1, 2, 3, 4, 5, or 6. Those are our 6 options when we spin that, or roll that die. Okay, then off of each of these, we'd show the options for the checkerboard. So options are either black or red. So black or red. It gets a little bit complicated here because you have to write kind of neatly, and I'm not doing a great job of that right now. But you want to show branches off of each of these numbers for black and red. I'm just going to shorten these a little bit just to have some space to write them. Okay, so then our outcomes here, well, there were 6 options for the first thing and 2 for this one. So total here should be 12 total outcomes. So I'm going to put those over here. Outcomes over here. Let's try again. So 1 with B, 1 with R, 2 with B, 2 with R, 3 with black, 3 with red, 4 black, 4 red, 5 black, 5 red, 6 black, 6 red. Those are all the combinations. If you just follow all the branches here, you'll get those outcomes there. If you count those up, there should be 12. And then we can answer the questions based on that. So what's the probability they'll land on a value greater than 3 and black? So black with a number greater than 3. So it can't be 3. So that would be 6 with black, 5 with black, 4 with black. Those would all be greater than 3 and black. So the probability of that, so probability of greater than 3 and black would be 3 out of our 12 possible, which if you want to make it into a percent, that's 1/4, which is 25%. All right, so you're going to do that same kind of thing with the other questions on the next couple pages here. So we've got similar thing here, spinner, and then easy or hard question. So do the same idea there. This one's a little bit tricky for number 3 here. 2 standard dice with 1 through 6. You might want to, because there's going to be kind of a ton of branches here, because 6 options, 6 options. So how many total options would that be? You can figure that out. So what I would do is like do the first die and then do the second die off of that. And you can kind of separate it so it's not all connected back to one tree. Like maybe over here we do 2, same thing. That might help you just keep this somewhat organized, because otherwise it'll be hard to fit all the combinations on one little page, or one little part of this page. So again, finish up that page, and then the last page here, very similar. Make